Thank you. Yeah, thanks a lot for invitation and just for talking about the previous talk. The Selfish Gene is a very nice book which actually answers your question about how we transport vehicle for bacteria. But I would like to start with a video. And so you can just start it now.
Technically, it's more important that they're the same than they're low because of this common mode rejection. So, for example, you could think about trying to make T3 worse, and then in theory, everything should look a little bit better. Yeah, I've never done that before. It's not a very clever idea. It's ideally you want to get the other ones better. I'm wondering, you could even try and use like toothpaste or something that's a little bit scrubby. I mean, the trouble is it's not a good idea because it will dry out, but you just want to slightly abrade the skin. But what you could do is take the cap off, wipe the areas down, clean it down and dry it out, and then just wipe it with alcohol.
We fixated two things. One is that it's really a platform for exploring art and science collaborations, and as for the something artistic, our dancers are actually adapting to the interfaces they are using. So they are literally becoming cyborgs. And that's the full idea behind this performance, is human and non-human in cyborg. How much will we preserve when we all become connected to the brain-computer interface and connected to these bigger systems. And that's where this idea of demultiplexia comes from, because I really like the word. In one sense, it's very technological. It's like demultiplexing of the signal. It's a telecom terminology. But at the same time, this ending, xia, it's almost like this, some kind of illness or some kind of psychological state of a cyborg. The main point is this neurocinematic system, which is a kind of forerunner of the future communication between humans, which doesn't involve text. So it's audiovisual communication by kind of rapid images or videos. I truly believe that we will enter the time when there will be no language. Technology-enabled telepathy.
Well, I've been always fascinated by art and art world, even though I'm engineer by first training. And if you see the writings of philosophers and psychologists, they often compare art with some kind of machine which, let's say, reading a book will convert you, and by the experience which is delivered by this book, you will become a different person. So, but as an engineer, I'm thinking about that, why don't we just build such a machine? And it's true that artists nowadays, they're really fascinated by new technologies. For example, our collaborator from previous projects, Marco Donnarumma, is a famous artist from Italy. His recent piece is this self-mutilating robot arm, which is learning and AI-based. And that's a perfect example of what the art is and what artist is doing with himself or herself. It's just self-destruction. In any case, what we do in our laboratory and what we are trying to build is implicit physiology-based interaction systems which will allow people then to experience different emotions and go through that as a labyrinth. So let's say, what is the brain-computer interface? In traditional definition, you have this loop, and that's very important, that the loop is closed. So it means that you operate with your brain some devices. It can be a prosthesis, it could be a web search, anything. And the most important thing is, of course, that you have a number of different stages. You have conversion of the signal, then you have feature extraction, learning algorithms in the middle there, and then you have the mapping. What I'm interested in is not a wheelchair or web manipulation, but more having a media which is interactive. It's like Pia said in her previous talk, neurocinematics, for example, or inactive cinema. But working on this performance, which you just saw and which we showed September last year in the framework of Estonian presidency in Brussels, I spent a year just working with different people from dance, from music, from visual art, and I understood that this idea of Neurotheatre it's quite powerful, because you have a number of things you can study in a different way. The most important part of Neurotheatre is that you can think now about audience-actor interaction. So usually and traditionally people are just passively watching a film or watching a performance, but now with these new technologies you can actually send your reactions to the dancers, to the actors, and basically all actors and dancers, they create this vibrant, like a multi-brain structure. So indeed, for example, in this performance, we had a number of parts. So we had two dancers who were communicating between each other using a neurocinematic system. So we had some images which would represent different emotional and like psychosomatic states, which I will talk about in a second. Then we also had audience. So some people were asked to come and sit on the stage during the performance, and they were also connected to the whole system, and they were manipulating using the brain, trying to kind of jam the signal between the two dancers. So that's how it looked like. Sorry, I have... Yes. That's a part of the performance. Okay, but so that's how it looked like. So you have two dancers, 3 screens, people on the stage, and we're still editing. We had a film crew also filming the full 3-day preparation and performance, so there would be more things to show. But if you think about what are the demultiplexia as an example of neurotheater, what it brought to the scientific side, there were like 3 different distinct items. One was this database, neurocinema research, which was very interesting to see the full system, because then we now start asking a different question. So what are these images and how we can make it work better with the semantic primes. Then another part of that was this collective brain, so these people who were on the stage, or the audience, how to analyze it, how, for example, you can understand that you, as a part of the audience, are the one who is really delivering the message to the dancers or actors. And then another part, which was really new thing, it was, as I call it, Neuro Choreography. There are some very few studies which addressed neurophysiology of the dancers, and it seems that it's a very interesting and new area, because what we basically tried to do, first of all, was to apply a very simple BCI-based approach. So we wanted really to just dancers concentrate on the emotional memories, but very fast we understood that that was not possible, because first of all this emotional experience wears out after training, like day after day, and then also sometimes these emotions were too strong and we didn't want to damage the dancers. So what we actually did then, after seeing what are recordings, what we can do, we converged to a new idea of these psychosomatic states, where we combine emotion on one side and then movement pattern on another side. Because, for example, if you think about emptiness or loneliness, these are not standard emotional names. This is something really like a psychosomatic state, which you can really dance. You know, like I actually learned a lot from the dancers in general while doing this performance, because you think about, say, like, imagine now you are like a plastic bag on an empty street of New York, and how you can dance that. So these kind of definitions are very different from very strange and strict ideas of emotions and in BCI world. But that's it. Thanks.